Good morning, my dear students. Welcome back to our next chemistry class. Today's class, we are going to discuss about the new lesson, P block elements. In your new syllabus, P block elements, they are given into two parts. One is P block elements 1 and another one is P block elements 2. In the periodic table where these P block elements are placed. In the periodic table, the P block elements are placed in the extreme right side of the periodic table. That is, from group 13 to group 18 are called P block elements. You know already we have learnt in 11th standard properties of S block elements and their compounds, important compounds we have learnt in 11th standard. And you know, totally the elements are classified into 4 blocks, S, P, D and F block elements. So in 11th standard, we have discussed S block elements and their compounds properties. In 12th standard, we are going to discuss about P block element, D block elements and F block elements. So in this lesson, we are going to discuss about P block elements. These P block elements are placed in the, already I said, right side of the periodic table, that is from group 13 to group 18. Okay, there are two parts in this P block elements 1. We are going to discuss about from group number 13 to group number 15. And balance 3 groups we are going to discuss in the next lesson, P block elements part 2. The elements, why they are called P block elements? Why they are called P block elements? Because these elements lost electron. These elements, electronic configuration we will write means the lost electron of these elements enters into the p orbitals. So that's why it is called P block elements. And already I said from group 13 to 18 in the modern periodic table are called as in P block elements. Group 13 family is nothing but in group 13 family the first element present is boron. So it is also called boron family. In group 14, that is nothing but the first element is carbon. So this group 14 is called as carbon family. And in group 15, nothing but nitrogen is the first element. So it is called as an nitrogen family, or we can say nitrogen family. Group 16 is nothing but oxygen is the first element present in that. So it is called oxygen family. Also it is called chalcogen family. Because why it is called chalcogen family means most of the ore forming elements are present in this group. So ore forming means chalcogen in the Greek word meaning. So chalcogen family. Oxygen family is also called chalcogen family. And the next group, nothing but fluorine, group 17 family. The group 17 family, the first element is nothing but fluorine. In this group 17 family is called as an halogen family because most of these elements exist as ions in the sea water. So nothing but halogen means in the Greek word salt producer. That's why this family is called as an halogen family. And the last group, nothing but group 18 family, are called as in noble gases. Okay, these elements have quite varied properties, and this block contains most of the elements are non-metals and few metals also present and metalloids also present. You know what is meant by metalloids? Metalloids is nothing but some elements both exhibit both metallic properties and non-metallic properties, so they are called as metalloids. Non-metallic elements of this group have more varied properties than the metals. So the elements of this block and their compounds play an important role in our daily life. For example, if you take oxygen is present in P block elements only, without molecular oxygen, we can't imagine the survival of living system. Yes. At the same time, the most abundant metal, aluminium, and its alloys have a plenty of applications from household utensils to parts of aircraft. And some semiconducting nature of the elements such as silicon and germanium also used in the field of modern electronics. So in this unit already I said we discussed the properties of first three groups, group number 13 to 15 of p block elements. Okay, they are called as in boron family, carbon family, nitrogen family, and we are going to discuss about these elements and their compounds, also important compounds properties also. Next, we are going to discuss about what are the general trends in properties of p block elements. Under the general trends in p block elements, properties of p block elements, the first one we are going to discuss about electronic configuration and oxidation state. You know what is meant by electronic configuration? We have learned already in lower classes also, and 10th 11th standard also we have learned how to write for one element or an atom electronic configuration. So electronic configuration of this p block elements, if we take, means the general electronic configuration is in the outermost cell ns2 np126. What is that? N indicate principal quantum number. Yes, you know, s orbital, and p, you know, that is p orbital. So what is that? Nothing but outermost electronic configuration of these p block elements is ns2 np126. ns2 np1 is nothing but general electronic configuration of first family in the p block elements. What is the first group or first block of elements, that is first group or first family present in this p block elements? Nothing but boron family. You know what is the atomic number of boron? Yes, 5. How we can write the electronic configuration? 1s2 2s2 2p1. So which is the outer cell for this one? Second cell is the outer cell for boron. So boron is nothing but what? In the outermost cell it can have 2s2 2p1. So generally we can write ns2 np1, that is nothing but what is that? Outermost cell, s orbital can have 2 electrons and p orbital is nothing but 1 electron. That is last electron of this group enters into the p orbital. Okay. This is first element of boron family. If you take other elements present in the boron family, aluminum, gallium, indium, thallium and all, if you take, means if you write the electronic configuration for these elements, the last outermost cell, the valence cell, can have ns2 np1 ns2 np1. First boron family 2s2 2p1, boron element 2s2 2p1. Next to boron, aluminum 3s2 3p1. It can have the outer cell electronic configuration. So like that way 4s2 4p1, 5s2 5p1, 6s2 6p1. Like that way will come the boron family elements electronic configuration, outer cell electronic configuration. Next to boron family, if you take, means carbon family. What's the atomic number of carbon? 6. How we can write the electronic configuration? 1s2 2s2 2p2, that is 2px1 2py1. Okay, so what is the outer cell? Second cell only outer cell. So in the second cell, outer cell, how many electrons it can have? It can have 2 electrons in s orbital and 2 electrons in p orbital. So what is that? Ns2 np2. Boron family Ns2 np1 and carbon family Ns2 np2. Okay va? If you take carbon family, the remaining elements present in the carbon family, and if you write the electronic configuration means that is nothing but in the outermost cell it can have Ns2 np2. That n may be differ if it is the second cell, third cell or fourth cell, depends upon the principal quantum number, it will be differ. Okay, next one, next to carbon family, nitrogen family. Nitrogen, what is the atomic number of nitrogen? 7. How we can write the electronic configuration for nitrogen? 1s2, 2s2, 2p3. Okay, so outer cell, second cell only. Nitrogen family, nitrogen can have outer cell, second cell, but in second cell there are 2 electrons in s orbital and 3 electrons in p orbital. So now nitrogen family can have the outer cell electronic configuration as ns2 np3. 2s2 2p3, 3s2 3p3, next elements 4s2 4p3, like that be the nitrogen family elements electronic configuration, outermost cell electronic configuration will come. Next to nitrogen family, oxygen family. What is the atomic number of oxygen? 8. How we can write the electronic configuration? 1s2, 2s2, 2p4. That is nothing but 2, 6. In the outermost cell, oxygen can have 6 electrons. That 6 electrons we will put in s orbital 2, the remaining 4 electrons in p orbital. So 2s2 2p4. 2s2 2p4. Okay, if you take the other elements present in the oxygen family, if we write the electronic configuration for those elements, so the outermost cell electronic configuration you will get ns2 np4. That is nothing but 2s2 2p4, 3s2 3p4, 4s2 4p4, like that way. Okay, next one, what is the halogen family first element present? Fluorine. What's the atomic number of fluorine? 9. How we can write the electronic configuration? 2, 7. That is nothing but 1s2, 2s2, 2p5. So second cell can have 2 electrons in s orbital and 5 electrons in p orbital. So 2s2, 2p5. All the elements present in the halogen family, in their outermost cell, it can have this type of electronic configuration only, nothing but ns2 np5. That is 2s2 2p5. Next element, next to oxygen, 3s2 3p5, 4s2 4p5, like that way will come. The last group of this p block elements is nothing but noble gases. Noble gases can have the outermost cell electronic configuration is nothing but 2s2 2p6. 2s2 2p6. That is nothing but noble gases can have the outermost cell completely filled p orbital. So it can have the stable electronic configuration, or we can say octet electronic configuration. Okay, but it can have a stable, we can say it is a stable, but it is the least reactive. It is the least reactive. Understood? Okay, so the elements of group 18 inert gas have completely filled p orbitals. So they are more stable but less reactivity. Okay, so elements of this block show variable oxidation state. Still we have discussed the general electronic configuration of p block elements. So the general electronic configuration of total p block elements, how we can write? ns2 np126. Each and every family we will take the electronic configuration of outermost cell, means the first family boron family ns2 np1, and next carbon ns2 np2, next nitrogen ns2 np3, next what is that? Oxygen ns2 np4, next halogen ns2 np5, and the noble gases ns2 np6. Okay, it can have. Next we are going to discuss about the properties. Is nothing but properties of p block element is nothing but oxidation state. Okay, now these p block elements show variable oxidation state, and their highest oxidation state is equal to the total number of valence electrons present in them. Okay, That is nothing but suppose totally how many electrons it can have, these p block elements in the outermost cell. 7 electrons means then 7 is the highest oxidation state. Example, if you take halogen family, so what is that? 7 is the valence electrons present in the halogen family, so 7. So that much highest oxidation state this p block elements exhibit. Unlike S block elements, which show only positive oxidation state, some of the P block elements show negative oxidation state also. Mostly halogens can have a strong tendency to gain an electron, and it will become a stable halide ion with a completely filled electronic configuration, and hence -1 oxidation state also. Halogens, mostly halogens will exhibit -1 oxidation state only. Similarly, other elements belonging to nitrogen family, that is nitrogen, and oxygen family, chalcogen groups, also show negative oxidation states. Next, metallic nature of p block elements. The tendency of an element to form a cation, that is how the element will form a cation by losing the electron, is known as what we can say electropositive, or otherwise we can say metallic character. This metallic character depends on the ionization energy of the elements. Generally, while moving down the group from top to bottom, ionization energy decreases, and hence the metallic character will be increases. So, on moving down the group, metallic character of p block elements increases. In p block, the elements present in the lower left part are metals and upper right part are non-metals. Elements of group 13, that is nothing but what? Boron family, have metallic character. All the elements are metallic character except the element boron, which is a metalloid. What is meant by metalloid? Already I said, the element which behaves both properties of metals and non-metals, then we can say that is a metalloid. The atomic radius of boron also very small, and it has a relatively high nuclear charge, and these properties are responsible for its non-metallic character. Yes, in the subsequent group, that is nothing but in the same group, the elements, other elements are nothing but non-metals. So, in the group 13 family, only first element boron is a metalloid. The remaining, if we move from top to bottom, non-metallic character increases. In group 14 elements also, carbon is a non-metal, but silicon, germanium and all metalloids. So in group 15, if you take, means nitrogen and phosphorus are non-metals, arsenic, antimony are metalloids. So if you take in group 16, oxygen family, oxygen, sulfur and selenium are non-metals, but tellurium is a metalloid. So all the elements of group 17 and 18, if you take, means halogen family and noble gases family, if you take, means they are non-metals only. Next, we are going to discuss about ionization enthalpy of p block elements. We have already learned that as we move down the group, that is from top to bottom, if we move means generally there is a steady decrease in the ionization energy. Last year itself we have discussed in periodic classification lesson, that is okay. So it's a steady decrease in ionization enthalpy or energy of the elements because of increase of atomic radius. So in p block elements, there are some minor deviations to this general trend. That is nothing but if you take in group 13, from boron to aluminium, ionization energy decreases as expected, but from aluminium to thallium, there is a marginal difference is there. So this is due to nothing but presence of inner d and f electron, which has a poor shielding effect. Shielding effect means what? Nothing but from between the nucleus and the outermost cell, so many inner cells are present, means so between the nucleus and the outermost cell electron, attraction is shielded by the inner cells, means we can say that is a shielding effect. So if we take the presence of inner electrons more, means d and f electrons, means which has a poor shielding effect compared to s and p electrons. So as a result, the effective nuclear charge on the valence electron increases. Okay. Same way, the similar trend is also observed in group 14 also, and the remaining groups 15 to 18 follow general trend. So in these groups, the ionization energy decreases as we move down the group. Here, poor shielding effect of F and D electrons are overcome by the increased shielding effect of the additional P electrons. So the ionization enthalpy or energy of elements successive groups is higher than the corresponding. That is nothing but successive group means if you take boron family in p block elements, boron family ionization energy, how it will become like that way we will take means it will be less compared to the next group. Example, next to boron family is carbon family. Compared to carbon family elements, ionization energy, boron family elements ionization energy is less. Understood? Okay. Next topic we are going to discuss is electronegativity. Electronegativity. As we moved, what is meant by electronegativity? This also we have discussed already in 11th standard. The element can have a tendency to attract the sad pair of electron towards itself. That property is called as an electronegativity. So as we move down 13th group, the electronegativity first same way like ionization energy decreases from boron to aluminum, and then it will be marginally increases for gallium. Therefore, there is no appreciable change happened. So, same trend is also observed in group 14th as well also. In other group, we move down the group, the electronegativity, only these two groups, some changes, some marginal changes, some appreciable changes will be there. But if you take the other groups and all, if you take means, so other groups, as we move down the group, electronegativity decreases. This observed trend can be correlated with their atomic radius. Okay. The next topic we are going to discuss is nothing but anomalous properties of the elements. What is meant by anomalous properties? If you take in p block elements, there are totally 6 families: boron family, carbon family, nitrogen family, oxygen family, halogen family, and noble gases. Okay, so if you take these blocks, that is these group elements, if you take means group 13 to 18, in this group, the first member of the elements properties or differ from the other elements present in each group from 13 to 18. That nothing but that difference in that property is nothing but, suppose if you take boron, in boron family other elements exhibit the same chemical properties, means boron will not exhibit the same chemical properties, it will be differ from the other elements. That property is called as an anomalous property or anomalous nature of elements. Okay. In p block elements, the first member of each group differs from the other elements of the corresponding group. So why? The reason. What are the following factors are the responsible for anomalous nature of the first element present in the periodic, that is p block elements, all the groups? The factors, what are the 3 factors they are saying means small size of the first member. First reason, the small size compared to other elements present in that corresponding group or otherwise corresponding family, the first element is a small size. And high ionization enthalpy, because already last year itself we have discussed, while move from left to right along a period in the periodic table, ionization energy will be increases. At the same time, what will happen? Move from top to bottom in the periodic table along a group, what is saying that nothing but ionization energy will be decreases. At the same time, same way electronegativity property also from left to right it will be increases, from top to bottom along the group it will be decreases. So due to the presence of high ionization energy and high electronegativity. The other elements, if you take in each group of p block elements, means compared to first element, the other elements electronegativity value and ionization value will be nothing but what they are saying, decreases. Third one, absence of d orbitals in their valence shell, because the first element present in all the groups of p block elements, if you take, means all the groups of p block elements if you take, means okay, small size, that is nothing but atomic number is less, so these elements can have the absence of d orbitals in their valence shell. Next, in the same topic, why the first element of each group varied, how it will be varied, that we are going to discuss. The first member of the group 13, boron, is a metalloid, but other are reactive metals. Boron shows the diagonal relationship with silicon. That is nothing but silicon is present in group 14. Boron is the first element in boron family. Silicon is the second element in carbon family. So between these two there is a diagonal relationship. Next, these are the two reasons. Another one, the oxides of boron and silicon are similar in their acidic nature. Both boron and silicon form covalent bonding that can be easily hydrolyzed also. Similarly, except boron trifluoride, halides of both elements are readily hydrolyzed. Next, we are going to discuss about group 14. The first element, carbon, is strictly non-metal, while the other elements are metalloids, silicon, germanium, etc. Are metals also present in this group 14 family, that is nothing but tin and lead. Unlike other elements of the group carbon, you know already we have discussed in 11th standard, carbon forms single bond, double bond and triple bond also with carbon and carbon and carbon and oxygen. Carbon and oxygen. So unlike other elements of the group, carbon can form multiple bonds such as C double bond C, C double bond O, etc. Carbon has a greater tendency also to form a chain of bonds with itself or with other atoms, which is known as catenation. Catenation is nothing but one of the property of carbon which can form with other carbon atom and it form a larger chain of compounds. There is a considerable decrease in catenation property down the group. Carbon can have a more catenation property than that of silicon and than that of germanium. Germanium and tin more or less equal and greater than that of lead, last element. Next, in group 15, also the first element, nitrogen, differs from the rest of the elements of the group. Like carbon, the nitrogen also can form a multiple bond like N double bond N, C double bond N, N double bond O, etc. So nitrogen is a diatomic gas. Unlike the other members of the group of elements, nitrogen is the diatomic gas. Similarly, in group 16, if you take, means the first element is oxygen. This also exists as a diatomic gas in this group. So due to its high electronegativity, which one? In group 16, oxygen can have a high electronegativity and it forms hydrogen bonds with hydrogen atom. Next, both nitrogen also will form with hydrogen bond and oxygen also will form hydrogen bond with hydrogen, because both are nothing but nitrogen, the nitrogen family, the nitrogen is the first element. In oxygen family, oxygen is the first element. So both are diatomic gases. At the same time, both can have a high electronegativity, so it forms hydrogen bonds. The next, the first element of the group 17, fluorine, is the most electronegative element, also behaves quite differently compared to the rest of the members of the group. Like oxygen, it also forms hydrogen bond because in halogen family, fluorine is a high electronegativity. At the same time, the atomic number is very small. There is nothing but small size. So it is also exhibits what hydrogen bonds with that is hydrogen bonds with what is that fluorine will form a hydrogen bond with hydrogen. It shows only -1 oxidation state, while the other halogens have +1, +3, +5 and +7 oxidation states. In addition to -1 oxidation state, fluorine is the strongest oxidizing agent and the most reactive element among the halogens. Next, inert pair effect. The next property we are going to discuss is inert pair effect. Already we know, we have learnt in 11th standard, alkaline and alkaline earth metals have an oxidation state of +1 and +2. Already in this lesson also we have discussed about oxidation state. What is meant by oxidation state or oxidation number? Same only, the actual charge possessed by an atom of an element in a compound. The charge, what is the charge possessed on that atom? That is the oxidation state or oxidation number. So alkali metals and alkaline earth metals can have +1 and +2 oxidation state. So totally how many number of valence electrons are present on that atom depends upon that oxidation state will come. Example, if you take the valence electrons are 2 or 3 means, then it can have the what is that oxidation state of +3, +5 like that way. Understood? Okay. So in addition, they also show variable oxidation state. In case of the heavier post-transition elements belonging to the group 13 to 16, the most stable oxidation state is 2, less than the group oxidation state, and there is a reluctance to exhibit the group of oxidation state. So let us consider group 13 elements. As we move from boron to heavier elements, there is an increasing tendency to have +1 oxidation state rather than the group oxidation state +3. For example, aluminium exhibit aluminium 3+ and aluminium 1+, but aluminium 3+ is more stable than that of aluminium 1+, while thallium +1 is more stable than that of thallium +3. Aluminium 3 chloride is stable, whereas thallium 3 chloride is highly unstable, because you know, one electron thallium suppose losing means it acquired the stable electronic configuration. Suppose thallium is losing the 3 electrons means, then it is not possible for thallium to acquire the octet or stable electronic configuration. That time thallium 3 oxidation state is a less stable or unstable compared to thallium 1. At the same time, if you take aluminium can have a 3 electrons in the valence shell, 3s2 3p1. That 3p1 electron it's losing means it is not possible to acquire the octet electronic configuration in the valence shell aluminium. So aluminium 1+ is nothing but it is the least stable or unstable compared to aluminium 3+. Why means aluminium in its valence shell it can have a 3 electrons. That 3 electron it's losing means that time aluminium acquire the nearest electronic configuration like neon stable electronic configuration. So aluminium 3 chloride compared to aluminium 1 chloride is more stable. Understood? So this shows that in so thus in heavier post-transition metals, the outer s electrons have a tendency to remain inert. So in this p block elements, okay, outermost, that is nothing but heavier post-transition metals if you take means, it can have, that is in the outer s electrons, ns electrons it can have. That outer ns electron can have a less tendency, or otherwise we can say that ns electrons remains inert. What is the meaning for inert? Not active or passive, and so reluctance to take part in the bonding. That's why it is not taking part for bonding, which is known as inert pair effect. So inert pair effect is nothing but the availability of what is that bonding in, less availability of bonding in ns electrons of p block elements is called as an inert pair effect. So this effect is also observed in group 14, 15 and 16 also it will be observed. Okay. Next one, allotropes. What is meant by allotropy and what is meant by allotropism? Okay, most of the P block elements exhibit allotropy or allotropism. What is meant by allotropy? It is nothing but it is the property of the element, okay, which can exist more than one crystalline or molecular form in the same physical state. That property of that element is called as an allotropy. The phenomenon is called as an allotropism. Already we have learnt in 10th standard that is nothing but carbon's allotropes are graphite, fullerene, diamond. Understood? So that is nothing but what? Allotropy of carbon or allotropes of carbon. Okay. So the phenomenon is called as an allotropy. Allo means in the Greek word, what is that? Another. And trope means what is that? Change. So another form we can say. And the different forms of an element are called as an allotropes. Many P block elements show allotropism, and some of the common allotropes are listed in your book like a tabular column. Boron, if you take means amorphous boron, orthorhombic boron, tetragonal boron, like that way. Carbon means diamond, graphite, fullerene, graphene, carbon, nanotubes, etc. like that way. Germanium, alpha germanium, beta germanium. Oxygen, dioxygen, ozone, sulfur, rhombus sulfur, monoclinic sulfur, selenium, red selenium, grey selenium, black selenium, like that way. Most of the P block elements exhibits allotropes. That allotropes they are given in the book. Next, we are going to discuss about group 13 family. Group 13 family is nothing but boron family. In boron family, if you take means, what are the elements present in boron family? Boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, thallium. What's the symbol for boron? B. Aluminium Al, gallium Ga, indium In, and what is the symbol for thallium? Tl. Understood? Okay. So boron family, or we can say what is that? Group 13 family. Occurrence of the group 13 family elements we are going to discuss. Mostly boron occurs as borates, and its important ores are borax and kernite. Aluminium is the most abundant metal and occur as oxides, and also it is found in aluminosilicate rocks. Commercially, it is extracted from its chief ore bauxite. Al2O3.2H2O is the formula for bauxite. The other elements of this group, if you take means only traces amounts only it will be present. The other elements, what are the other elements? Gallium, indium, thallium occur as their sulfides. Boron and aluminum as their oxides, and gallium, indium, thallium occur as their sulfides. If you take gallium present in the group is nothing but it can have low melting point, and gallium metal is melted in our palm itself. Understood? And thallium is nothing but it is one of the toxic element. Understand? So what are the 5 elements present in the boron family? Boron, aluminium, gallium, indium, thallium. Next we are going to discuss about some of the physical properties of boron family elements. Physical state. All the 5 elements in this group are solid state, and you know the atomic number also. For boron 5, aluminium 13, gallium 31, 49 for indium, and 81 for thallium. If you write the electronic configuration for these all the 5 elements, the outermost shell it can have 3 electrons, that is nothing but in s orbital 2 electron and p orbital 1 electron. So it can have the electronic configuration ns2 np1. Understood? Next one, we are going to discuss about the physical properties like boiling point, also they are given in the book, and density, atomic radius. Atomic radius from boron to aluminium decreases, again gallium to thallium it will be increases, and if you take the boiling point from boron to thallium it will be decreases, boron more, and the remaining it will be decreases till thallium. And melting point if you take means nothing but boron can have a high melting point than that of aluminum, but if we move from boron to what is the thallium, what happened for melting point? Decreases, and finally in indium and thallium it will be decreases and then increases. Okay, understood. Next we are going to discuss about chemical properties of boron. Under the chemical properties of boron, nothing but many of its compounds are electron deficient. If you take boron family elements, if you take and it form the compound, in that compound how these boron family elements are means they are electron deficient and has a unusual type of covalent bonding, which is due to the small size and high ionization energy. Okay, so first under the chemical properties of boron, first one we are going to discuss is formation of metal borides. Many metals except alkali metals, boron combined with the other metals means it will form borides with the formula Mx and By. Okay, so direct combination of metals with boron. Chromium example, chromium combined with number of molecules of or number of atoms of boron under 1500 Kelvin, it will form chromium boride, CrBn times. Next one, reduction of boron trihalides. Suppose boron trihalide like BCl3, BCl5, BBr3, boron tribromide. So like that way if we take the boron trihalides and that will be, there is more reduction of that will be undergo reduction. Boron trihalide will undergo reduction with metal assisted by dihydrogen gives metal boride. So nothing but BCl3, boron trichloride combined with metal like tungsten in the presence of what? Hydrogen, because reduction means addition of hydrogen. Under 1500 Kelvin it will form what? Tungsten boride, and chlorine gas and hydrogen chloride all will be removed. Next one, formation of hydrides. This boron trifluoride combined with metallic hydride like sodium hydride, nothing but BF3 plus NaH in the presence of 450 Kelvin, it will form B2H6, nothing but what they are saying, diborane, by the removal of what? NaF, sodium fluoride, as the product. So boron does not react directly with hydrogen, however it forms a variety of hydrides called as an boranes. So the simplest borane is diborane. Diborane formula is nothing but B2H6. So how diborane is occurred or manufactured means boron trifluoride combined with metallic hydride like sodium hydride. So that time diborane will be occurred by the removal of what they are saying, NaF. So formation of boron trihalides. Nothing but what is that? Boron combined with halogen. Example, if you take boron combined with generally halogens means X2. So B plus X2 will give what as the product? BX3 as the product. Okay, next one, formation of boron nitride. Nothing but boron burns with dinitrogen at high temperature, it forms boron nitride. Nothing but B plus N2 will give Bn. Formation of oxides. Next one, boron heated with oxygen. Boron and oxygen under 900 Kelvin it will be heated means then it will form nothing but boron trioxide as the product. Next one, reaction with acid and alkali. Okay, boron react with acid like sulfuric acid and acid like nitric acid. Acid like sulfuric acid and acid like nitric acid. What will happen? It will form boric acid as the product. At the same time, boron combined with sulfuric acid means it will be remove sulfur trioxide. Boron combined with nitric acid means by the main product boric acid, and the byproduct is nothing but what they are saying, nitrogen dioxide. So there is before this sulfur dioxide and here nitrogen dioxide. So sulfuric acid will be heated with boron means sulfur dioxide gas is liberated. Boron is heated with nitric acid, means nitrogen dioxide gas will be liberated. Next, boron, under the same topic, boron react with fused sodium hydroxide. Fused sodium hydroxide and the forms what sodium borate as the product. So boron plus NaOH will give Na3BO, that is nothing but what, Na3BO3, sodium borate, by the removal of H2, by the removal of H2. Okay, so boron react with fused sodium hydroxide, fused sodium hydroxide, that is nothing but molten sodium hydroxide, it forms sodium borate. So the equation how we can write means 2B plus 6 NaOH gives 2 Na3BO3 plus 3 H2 gas will be liberated. Next one, uses of boron. Boron has the capacity to absorb neutrons. Boron has the capacity to absorb neutrons, hence its isotope, it's one of the isotope. What is one of the isotope of boron? B510 is used as a moderator in nuclear power generator or nuclear reactor. So first uses is nothing but it is used as a what, moderator in nuclear reactors. Next one, amorphous boron is used as a rocket fuel igniter. Amorphous boron is used as a rocket fuel igniter, and boron is essential for the cell walls of plants. Boron is the essential for the cell walls of plants. Okay. Fourth use of boron is compounds of boron have many applications. For example, it is used in eye drops, antiseptic, washing powders, etc. Contains boric acid and borax. So in the manufacture of Pyrex glass, boric oxide is used. Next, we are going to discuss the next compounds of boron is nothing but that is first compound. Before this, we have discussed about boron preparation, properties, uses. Next, we are going to discuss about first boron compound is nothing but borax. You know what is the formula for borax? Na2B4O7.10H2O. This is the formula for borax. How it will be prepared? It will be prepared from columnite ore. Columnite ore is nothing but Ca2B6O11. Columnite ore formula Ca2B6O11. This columnite solution will be treated with sodium carbonate. So that time we are getting the product. Main product is Na2B4O7, nothing but borax and calcium carbonate. Calcium hydroxide also will be removed. Next, borax is the normally formulated. How it will be normally formulated means Na2B4O7.10H2O, but it contains tetranuclear units, that is nothing but B4O7 OH 4 times. This form is known as prismatic form. Borax also exists two other forms, namely dweller or octahedral borax, and borax glass also there, that is also formula is same, Na2B4O7. Next, properties. Under the borax properties, first one we are going to discuss is it will undergo hydrolysis. Nothing but borax is basic in nature, so its solution in hot water is alkaline. Its solution in hot water is alkaline as it dissociates into boric acid and sodium hydroxide. So Na2B4O7 plus 7H2O gives 4H3BO3. Boric acid formula H3BO3 by the removal of two molecules of sodium hydroxide NaOH. Next, on heating, it forms a transparent borax beads. It is called as this test is called as an borax bead test. Very important, 2 mark or 3 mark question. Borax bead test. For that borax bead test, this borax is used. So borax will be heated, means totally all the molecules, 10 molecules of water will be removed, and it will give what? Na2B4O7. Again, that will be heated, means it will form sodium metaborate and boron trioxide will be formed. Okay, so this is nothing but transparent borax beads. Next, borax react with acids to form sparingly soluble boric acid. Example, if you take, so borax will be treated with solution of hydrochloric acid. It will form boric acid and sodium chloride will be removed. Na2B4O7 plus 2HCl plus 7H2O will give 4H3BO3 plus 2 NaCl. Same way, borax is treated with sulfuric acid in the presence of water. It will give boric acid and sodium sulfate as the product. Okay, next one, when it is treated with ammonium chloride, what is the formula for ammonium chloride? NH4Cl. So Na2B4O7 combined with ammonium chloride, it will form two molecules of NaCl at the same time. That is, Na and Cl will be removed as an NaCl. Boron and nitrogen will form boron nitride, and boron and oxygen will form boron trioxide, and water molecule will be removed. Next, uses of borax. Borax is used for the identification of colored metal ions. Boron is used for the identification of colored metal ions, and it is used in the manufacture of optical and borosilicate glass enamels and glasses for pottery. Okay, pottery glasses, we can say pottery glasses, for the manufacture of borosilicate glass and optical glass enamels and what, pottery glass. Next one, it is also used as a flux in metallurgy. It is also used as a flux in metallurgy. Why? The purpose we are adding the flux in metallurgy due to the extraction of metals from their ores. It is nothing but to reduce the fusion temperature of the mixer. For that only we are adding the flux in metallurgy, and also act as a preservative also act as a preservative also. Understood? Okay, next one, boric acid. Boric acid, only preparation we can see now. What is the formula for boric acid? H3BO3. H3BO3. What is the formula for boric acid? H3BO3. Understood? Okay, so now the preparation. Boric acid is prepared from nothing but columnite ore and borax. Okay, so borax we are taking. What is the formula for borax? Already we have discussed, Na2B4O7. What is the columnite ore formula? Ca2B6O11. So this will be treated with what? Sulfuric acid in the presence of water. Borax will be treated with sulfuric acid in the presence of water. Sodium sulfate and boric acid will be formed. Columnite ore is treated with sulfuric acid and sulfur dioxide. It will form what as the product? Calcium bisulfite as the product, and the main product is nothing but boric acid. So this is the method of preparation of what? Boric acid. What is the formula for boric acid? H3BO3. Understood? Next properties. Boric acid will undergo hydrolysis. Boric acid will undergo hydrolysis because it is a colorless transparent crystal. It is a very weak monobasic acid also, and it accepts hydroxyl ion rather than the donating the proton. So BOH thrice also boric acid formula. H3BO3 also boric acid formula. So it will be treated with two molecules of water. It will form H3O plus BOH 4 times minus. So it react with sodium hydroxide. Which one react with sodium hydroxide? Nothing but H3BO3 react with sodium hydroxide. It will form sodium metaborate as the product. At the same time, now boric acid also treated with two molecules of sodium hydroxide. It will form Na2B4O7. Nothing but what? Borax. And it will form what as the product? Water as the byproduct. Okay, NaOH plus H3BO3 will give NaBO2 plus 2H2O. Na2NaOH plus 4H3BO3 gives Na2B4O7 plus H2O. Next one, we are going to discuss about boric acid action of heat. Okay, boric acid will undergo heat under 373 Kelvin. It will form metaboric acid. That is nothing but what? It will be formed first as the product, metaboric acid as the product. After that metaboric acid will be heated under the temperature of 413 Kelvin. It will form tetraboric acid as the product. Again it will undergo red hot. Which one? That Tetraboric acid H2B4O7 will undergo red hot. It will give what as the product? Boron trioxide as the product by the removal of water molecule. Once again I will repeat, action of heat of boric acid. Boric acid will be heated under 373 Kelvin. It will form sodium that is metaboric acid as the product, and that metaboric acid is again treated with or otherwise heated with under 413 Kelvin, 413 Kelvin. It will form what as the product? H2B4, what is that? O7 as the product, tetraboric acid. The tetraboric acid will undergo red hot heat and it will give boron trioxide as the product and by the removal of water molecule. Next one, action of ammonia. Action of ammonia is called as an ammonolysis. What is that? Ammonolysis. So what they are saying, boric acid combined with ammonia. Boric acid combined with ammonia, it will form boron nitride and water molecule will be removed. Next, boric acid combined with ethyl alcohol in the presence of concentrated sulfuric acid. It will undergo what? It will react with boric acid, react with ethyl alcohol. In the presence of concentrated sulfuric acid, it will form a green edged flame, and this reaction is used to identify the presence of borate. Presence of what they are saying? Borate as the product. Next one, formation of boron trifluoride. How boric acid is useful for the preparation of or formation of boron trifluoride means calcium fluoride CaF2 is treated with sulfuric acid and boric acid. That time calcium and sulfate will be removed as calcium sulfate, H and O will be removed as a water molecule, and 2 molecules of boron trifluoride will be formed, BF3. Borax when heated with soda as it gives borax. What it gives? Borax. So Na2CO3 plus H3BO3 or 4, or we can say how for boric acid form either H3BO3 we can say, or we can say 4BOH thrice. So it will give borax Na2B4O7 by the removal of carbon dioxide and water. Next, structure of boric acid. Boric acid has a 2-dimensional layered structure. It consists of BO3 3 minus boric acid has a 2-dimensional layer structure. 2-dimensional layer structure, and it contains what? It contains BO3 3 minus unit, and these are linked to each other by hydrogen bonds as shown in the figure. Next, boric acid uses of boric acid. Boric acid is used in the manufacture of pottery glasses, enamels and pigments. It is used as an antiseptic and eye lotion, and it is also used as a food preservative also. Thank you.